Can you solve this geometry challenge? Here's the question. So let's begin with a quarter circle. Now let's draw a segment that divides the radius into two equal parts. And let's drop a perpendicular segment that is directly to the endpoint of this radius. Now the question is, what is the area of this shaded region? Now pause this video right now and see if you can answer this question. And of course, if you're done, post your answer in the comment section down below, because I will show you the solution in 3, 2, 1. Alright, so given this figure, the goal is to find the area of this shaded region. Now, to solve this, what we're going to do is to use the given information. First, this segment divides this radius into equal parts. So we know the length of the radius is 10 centimeters. So this is 5 centimeters. And then, what we're going to do, instead of using a quarter circle, what we're going to do is to use a semicircle. So let's create another quarter circle like this to create a semicircle. Now, what is the good thing of using semicircle? Now, if we extend this segment, this is directly to the end point of this semicircle. Now, why is that? Because one of the property of a right triangle inside the circle is the hypotenuse of that right triangle is the diameter of the circle. Alright, so this is a right triangle inside the circle if we complete this, and this part is the diameter for sure. So we know this is the radius, or simply equal to 10 centimeters also. Now the question is, how long is this segment, or the hypotenuse of this white right triangle? So using Pythagorean theorem, we have your square root of 10 squared plus 5 squared, which is 100 plus 25. And if we add, we have 125, which is 25 times 5. Square root of 25 is 5, so the length is just 5 times square root of 5. So this is the length of this hypotenuse of this white right triangle. Now, the main goal is to get the area of the shaded region. Don't forget that. And to get this area, what we're going to do is to let this x and the other side be equal to y. Because we see here two right triangles, so if we get the value of x and y, then we can now get the area of this right triangle. So we know the area of this because we now have the height and the base. So we need x and y because this is the height and the base of this right triangle. So the goal now is to find the values of x and y. But before that, let's have the names of these endpoints that we need to get the values of x and y. Alright, this is enough. Now, notice angle A is equal or congruent to angle A for sure, by reflexive property. And then, since we have here two right triangles, triangle ADE and triangle ACB. Now, what we notice is if angle A is the same thing as angle A for sure, therefore, angle AED is equal to angle ABC, which is, it follows that triangles ADE is similar to triangle ACB. Now, since they are similar, we can use their similarity to solve for the value of x and y. So we can say that the side length or the ratio of BC over AB is equal to the ratio of ED and AE, which is, we know their measurement. BC is x, AB is 20, ED is 5, AE is 5 times square root of 5. Now, 5 over 5 times square root of 5, we can simplify this as 1 over square root of 5. And to solve for the value of x, multiply both sides by 20, and x equals 20 over square root of 5. Now, rationalize this, multiply the numerator and denominator by square root of 5. So we have that x equals 4 times square root of 5. So now we found out that x equals 4 times square root of 5. Alright, now how about the value of y? Now, let's use this right triangle. To use this right triangle, we need the length of EB. And we know EB is equal to AE by symmetry. Therefore, this EB simply equal to 5 times square root of 5. Now, this is very familiar. 5 times square root of 5, the hypotenuse. One leg is 4 times square root of 5. So the other leg, very sure, is 3 times square root of 5, or 3, 4, 5 right triangle, and multiply it by the factor of square root of 5. So we know that y equals 3 times square root of 5. Now at this point, we know x and y. We now have the height and the base, so we can now get the area of the blue region. So using the formula of a right triangle, y½ times base times height. So the bottom right triangle, we have 5 times 10 is 50 divided by 2, we have 25 square centimeters. And on the top, we have 3 times square root of 5 times 4 times square root of 5, we have 12 times 5, we have 60 divided by 2 is 30 square centimeters. Therefore, the area of the blue shaded region must be equal to 25 plus 30, which is equivalent to 55 square centimeters. Therefore, the area of the shaded region in this figure is equal to 55 square centimeters. And as always, we are done.